Hey guys, I'm Voyen and welcome to part 5 of making a video player inside of Godot. In the last episode we made the audio work. We made it work so we can get the audio and let it play inside of Godot. But that code was not very optimized and there were a couple of mistakes which also somebody in the Discord server mentioned out, and together we worked on optimizing the code a little bit. So that's what we'll be going over today. And I'll also show how to implement multi-threading inside of the decoding for the audio. And first up, let's go into our Godot project. And let's see how long it actually takes to get the audio. So we create a new variable, start time, time.get use seconds. I think that's the one. So this will basically get microseconds, and that returns an integer, so let's make this an integer. And then over here, we basically just print how long it took. So we take this one again, and we do it minus start time. So normally this should not take too long. Hey guys, I'm Voyen and welcome to... Okay, so we got our number. So we need to get better than, do better than this number. So this is before optimizing. Let's see if we can get this faster. First of all, what we will do is go to our C++ file, so our video.cpp. This is the only file that we'll be working in today. And we go all the way to the top where we open the codec for audio. And we start working on the multi-threading. And basically what this piece of code that we'll be writing will do is it will set the codec to automatically determine how many threads can be used for decoding the job, like which amount will be better and which amount is actually available, and is multi-threading actually an option on that current running machine. So first we go into the AV codec context audio and I think thread count, we put this on 0. I think that's how we are supposed to do it. Is used to decide how many, yeah, okay. And next we need to check if we actually have the capabilities. So AV codec audio capabilities, and we need to have an AV codec capabilities and I think frame threads. And if that's correct, then we change the AV codec contexts audio. Then we change the thread type to FF frame thread frame, FF thread frame. So main XL IPS, new fields can be added. Yeah, I don't think this is anything that we need to care too much about. But yeah, what this basically will do is check if there is frame level multi-threading. If that's not the case, else if, again, same part. But this time we check for AV codec slice threads. If that is there, if that exists, if that's possible, then we do the same thing but with slice. And codec supports slice-based or partition-based multi-threading. So if that's possible, we could do that. And worst case scenario, if it's not possible, we just don't have multi-threading. And when that's the case, we basically put the thread count on 1, because we need at least one thread to work with. So normally this should work for getting multi-threading enabled. And let's put a quick comment here. That's what we need for multi-threading. So let's quickly compile. And when that is done, let's go over here again. Let's add our comments with multi-threading. Let's see how much of an improvement we get. Okay, that's strange. That's actually longer. It takes actually longer. Okay, I should have probably done it a couple of times because right now we get a lower number. Let's try one more time. Hey guys, I'm Voyen and welcome to part 4. And now it's higher again. Okay, so it's around this number. So with multi-threading, it actually takes longer. So something is probably not going correct over here. Let's see what thread type we actually have when we use this. So utility functions, print. Let's quickly build this. And let's see what we actually have, if multi-threading is enabled or not. Welcome. Okay, so we have 3, so let's go over here. 3, I have no idea what that is. Okay, how else can we do this? Let's remove this print, and this is slice. Hey guys, I'm Volin, and welcome to part 4 on how... Okay, no, that's around the same, but it also does not print anything, so we don't actually have any multi-threading on our system. So basically this was probably just margin of error, so it's probably around the same, because my system is too old to have multi-threading apparently. Okay, but that's multi-threading done. So on systems who support it, my PC is just not strong enough. Okay, and then we go over to the get audio function, because we need to do a couple of changes in here. Last episode I changed this to -1, but because we will always use the same stream that we already have, we do AV stream audio, and we set this to the index. Now, this will also work. This was correct to begin with, so that was a change that I should not have made. And next up, if you go down, you may remember that we created a vector, and we actually never ended up using this, so let's remove this line because it's really not needed. And we do ×2 here, and that's probably because of the whole stereo thing inside of Godot. So let's remove this, and let's check if there's actually like stereo or not. So if stereo is an option, well, if the audio is in stereo and not mono, we need to do L embedded line size times 2. Also, this byte array, let's just not use this anymore, and also this code, we don't really need to use it anymore, because we will do something completely else. Also, for the people who still want to use this should be a U, and the reason why this is all changing is because I basically noticed this is already a uint8, same as a packed byte array. So if we go into the code of packed byte array, and let's go to the ptwr to get the pointer, you can see it's already an unsigned integer 8. So yeah, we didn't actually need to do this whole conversion here. We can basically just copy the memory directly into the array. Also, we should actually get it from the local AV new frame and not from normal AV frame, just in case that number of samples changes. Normally that should not be the case, but in case it does. Also, this is also not really an issue apparently, so let's also remove this check. Over here we need this, and we need to do it equals. So L embedded line size, if there is stereo audio, we do this ×2. Now I don't have any, like I mentioned before, I don't have any like 5.1 audio setup, and I don't even know how to make those kind of video files, so I cannot really help with that. If the opportunity comes that I could work on that, then I will try to implement this, and this will probably need to change then, but until then, this is how it will work. Next up, we need to create a new variable actually. So we have a size t, and we call it L audio size, because we need to take in mind, like we need to remember how big the audio actually is. Because instead of using the, let's go over here, instead of using this byte array, we'll still use this, but for the video part, we won't use it for the audio anymore. Instead of using that, we will directly write to this L audio data. So let's assign a new packed byte array to this L audio data, and over here L audio data dot resize, and we need to resize this with L audio size plus the L unpadded line size. And we, after copying the memory, we also need to increase this by unpadded line size. I should just call this byte size kinda. I think this will make a little bit more sense. Okay, and now mem copy. We need to still do the mem copy that we had before, but this time we assign it directly to the L audio data. Over here, boom, boom, boom. This needs to be between brackets. We need to get the pointer, and we need to assign this to L audio data, so it knows from what point in the array it needs to start assigning the data. L audio size. Okay, and over here we just need the the source. Let's go in the correct area. So we need the source, and the source is basically AV new frame, extended data, and 0. For video files we will be using normal data, and then we will need data 1, 2, and 3. Well, 0, 1, 2, because of RGB, but that's for later. And over here we need the L byte size, and this should normally work. So if you will build this, let's go over here already. After optimizing, I'm not 100% certain if there will actually be like an increase or not, but the code looks arguably cleaner. And we remove some unnecessary parts and fix some stuff that I messed up in the last part. So let's run this. Let's hope there's a performance increase.
Hey guys, I'm Volin and welcome to
I think that's a performance increase. That's okay, so that's just one test, but that's already kind of an increase. Yeah, okay, so it's around this area. Let's try one more time so you have a little bit of wider.
Hey guys, I'm Volin.
Okay, so that's even lower. So we got almost half of the performance extra. Okay, so that is basically it for this video. I was going to test bitrate, but I don't think this is actually correct. So let's quickly go over that. I don't think this will probably create a spaghetti sounds. Okay, so if you want to sound like a chipmunk, that's what you need to do. Let's save this, and we basically don't really need this anymore. So let's just remove the timing stuff because optimizing is basically complete. Thank you all for watching. I hope you found this interesting, and like always, thanks a lot to all my Ko-fi supporters for making this all possible. And also thanks a lot to the person on the Discord server for helping me out with the whole FFmpeg and C++ code, because it's really helpful, because my C++ knowledge, it's quite low. It's not that much. I know the basics, but the whole time, the moment that it comes to like memory management and optimizing things inside of C++, that's still something I'm working on. So yeah, bear with me. So yeah, thank you all for watching, and I hope to see you in the next episode where we will be working on frame seeking, on actual getting the video frames of a video file. So yeah, that will be interesting. Thank you all for watching, and I'll see you in the next one. Bye bye.